Hello and welcome to section 10.8, which is on geometric probability. So geometric probability, points on a segment or in a region of a plane represent outcomes. It is the ratio that involves geometric measures such as length or area. So the probability that a random point is on a segment of a line is the ratio of the length of the segment to the length of the entire line. For example, use this diagram to find the probability that H lies on SR. Point H on ST is selected at random, and it would have to be at random, otherwise it's not probability. So what we have to do here is figure out how long is S over to R. Well, you can see it's from here to here, 1 to 11, so it's 10. And the length of ST, the whole thing, is 1 to 21, which would mean that it is 20. So the probability that point H is on that half is half, because it's cut in half. So you'd say it's 1/2, or if you change it to a probability, you would say 50% chance that it is on S to R out of the whole line S to T. The probability that a point is in a region is the ratio of the selected area to the entire area. So part of it compared to the whole, just like with that line, except now it's an actual region of area instead of just a line, a length. So a triangle is inscribed in a square, like the picture I have drawn here. Point T in the square is selected at random. What is the probability that T lies in the shaded region? And so we're going to say the shaded region is that part. Okay, so the area of the square, well, that's pretty easy. 5 times 5. The area of the square is 25 square inches. Then you would also need to find the area of this triangle right here, which would be half of 5 by 5. So in other words, it is 12.5 square inches. Now you compare the ratio, or the areas. So you'd have 12.5 over 25. Obviously, that is 1/2. And so you have 1 and 2 shot, or 50% chance that point T is inside of the triangle, that part of the area of that figure. So we're going to use this more the next time I see you. Bring that knowledge with you, and have a good night.